Hello, everyone, and welcome to our webinar. Thank you for joining us for Accelerate Software Delivery with Database DevOps for AWS. We're so excited to have you here. I want to go over a few housekeeping items before we get started. So questions are welcome throughout the webinar, and we ask that you post those in the Q&A tab, and we'll answer those at the end of the presentation. We also will have some live polls during the webinar, so please participate in those so we can engage with each other and find out where we're all coming from. We also are recording this webinar, and we will be sending it via email to you tomorrow. All right, I'm so excited to introduce our host for today's webinar. First, we have Marina Novikova, Senior Partner Solution Architect at AWS. Marina has been at Amazon for more than 4 years, and she currently supports the APN Global Startup Program. Her focus is on the existing AWS architecture validation and improvements, planning new workloads and integrations with AWS services, and supporting general technical enablement. Marina has a master's degree in computer science and has over 19 years of experience in developing large-scale systems for financial services. And also joining us today is Pete Pickerell, co-founder and principal product strategist here at Liquibase. Pete works directly with our vast community of customers, partners, and open source users to understand their needs and drive our product strategy and direction to deliver the promise of DevOps for the database. And he also has a pretty cool demo to show us today. All right, I wanted to take a moment. Many of you completed a survey that we had upon registration for today's webinar. And the question was, which challenges are you aiming to tackle with database DevOps? And so I wanted to kind of go over, who's represented here and what challenges we're all seeing. So, the biggest challenge it looks like is a third of us are seeing a challenge tackling CI/CD and automation. Followed by that, closely tied are cloud migration and modernization, also quality control, performance, observability, and scalability. And then lastly, kind of tied are cost efficiency and operational improvement, security, compliance, and business-specific needs.
Definitely doesn't surprise me. I think it sure is like we see a very often question to AWS is like how to do things right and what the best practice is. So we'll try to talk a little bit.
Awesome. Wonderful. Okay, well, so before we officially dive in, we wanted to go ahead and start with a live poll. So let's get started. We wanted to ask which phase best aligns with your organization's DevOps maturity. So we've got initial, so traditional environment with dev and ops separate. Then we've got managed, so beginning stages are focused on agility with initial automation. Then we have defined, so org-wide transformation begins with defined process, measured, process and automation with continuous improvement, and then finally optimized. Achievements are visible, team gaps disappear. All right, so let's see where we landed. It looks like almost half of us are in managed stage, a third of us are in initial, and then about the remainder of us are in defined and measured.
It's interesting that kind of aligns with the first poll as well. What struck me about the first poll is that each category kind of built on the other. First, you're trying to solve just basic automation, and then you're trying to standardize, improve, and then roll it out org-wide and refine. So yeah, I mean, this lines up very nicely with that. I think we kind of see where the big lump is in people's DevOps journey for sure.
Mm-hmm.
And they definitely align with the challenge to make sure that culture, process, and tool aligns and ambiguity of choosing the right ones for organization. I think it's definitely stop the process. You need all of them to be like at the last stage.
Mm-hmm.
Absolutely.
Mm-hmm. Wonderful. Okay, well, thank you all for participating with that. Our agenda, here's what we're going to be talking about today. So we're going to start with the evolution of DevOps. Then we'll go into why DevOps matters and common challenges we see. bringing DevOps to the database, and then Pete will walk us through a live demo, and then we'll be able to answer any questions that you have at the end. So with that, Marina, I will pass it over to you.
Thank you. Hello, everyone. Good morning, good afternoon, whenever you're joining from. Super excited to be at this webinar with Liquibase. I'm super excited with their technology, and especially with seeing how difficult it is for most of organizations to come to the point of the need of database DevOps. So to dive into the topic and understand is like where from the challenges are coming and what the challenges, I wanted to start to look a little bit back into the history. If you remember, like we all started from monolith application, but database was part of it. It was just like a lot of efforts to maintain database and was sitting like right next to host application. Then we moved to free tier application. And now we are in the modern system phase when every single microserver has its own data store very often. Each service is built for specific need as well as purpose-built databases. You need to think about what is data access partners and choose the database for that need. One size doesn't fit all, and depends on that, on data need, for each modular service, you can come and choose like the use case of a massive data volume, high-speed render, and data warehousing, and go choose like one of the database for your need is like relation database, serverless server, Redshift for data warehousing, DynamoDB as key-value highly scalable database, or DocDB for unstructured data and known as a NoSQL database. Think about that. You cannot design for NoSQL database the same way as for structured data. You cannot think just in terms of data tables and joins. Next slide, please. So let's look at what is a cloud-first mentality and where we are, because cloud's actually accelerated system maturity at the microservice stage. Let's start to think about it. Back in the days, we have a totally separated team for IT, which managed hardware, and totally separate database administrator to manage databases. And now we're at the stage of the platform engineering already. So let's look at this in details. AWS helps to solve database management tasks by providing managed service and serverless database. It became easy to maintain database, so the main of the operation overhead of database administrator went away by cloud providing the services. But still, the number of stores grow and different type of data stores present in the application. So what and how operation basically change from database administrator to the cloud-first mentality. Cloud provides more capability to design for 99% availability of application. So how we achieve this availability? We need still to perform database upgrades and database schema upgrades. We need to make sure that deployment strategy, blue-green deployment or feature flags to like separate the traffic between different databases still work. So we have 4 different type of the operation for database. First one, and like most one which we wanted to discuss today, is a CI/CD, continuous integration delivery process. Look at that, integration of database data schema and logic changes to application development efforts, and to provide immediate feedback to developers on any issues which can rise. Database continuous delivery produces reusable database code. So our CI/CD uses the same tools as application code and allows to follow the same processes as the stages as application developers are familiar with. So don't forget about like easy rollback for databases as well. We need to perform in the case something fails, right? The next one is the backup and disaster recovery. Databases are very critical pieces of the system, and they need to be resilient. Organization teams need to think ahead of time about backup strategy and disaster recovery when it's applicable to the system. Mature DevOps processes, engineering practice like house engineering and game days help to ensure that backup and data DR strategies and organization work as expected, and there is no downtime in production. The next one is a test data management, when we need real production data to actually have like our CI/CD pipeline matured. CI/CD practices, to be complete, need access to both quality data and with edge cases which cause issues in production. So typically, we bring the backup from production, and we wanted to this backup like to have obfuscated data, but we wanted this backup to have a whole variety of data available in production, so we can change, like test our changes on this backup before we roll it into production. And the last one is, but very important one, is actual observability into applications. With a modern application being highly distributed, it's important to get visibility into third-party components like payments, location services, and even database changes. You want to have a complete picture, including database changes when debugging your application. The good example would be like if your transaction for the payment fails, is it caused by payment gateway being down, or is it caused by like last database change rolled into production? Next slide, please. So why DevOps matter and why it matters for database and what are common challenges? It's not surprising that like challenges the same. And it's no longer a question why DevOps matters and why database actually DevOps should be included in the regular DevOps practices. Time to market is critical for organizations to run their business. We wanted to roll out rapid database. We wanted still to have a rapid deployments and roll out database changes without affecting the production in our business. So the challenges is totally the same. We still wanna select the right tools. We still wanna have a right metrics, DORA metrics, the frequency of deployment, like how often they fail. We still have this increasing complexity variety of data stores when we want the same tools working for absolutely all different data stores. We want to like have like as many deployments as we need if we need release like any changes into production often. We still have a cross-team cross-functional team like challenge, but it's a little less than back in the days, because modern tools actually provide a single interface for a lot of different teams to access. And the platform engineering trend is actually like defined to solve these challenges when like we can define the governance for developers, and developers can easily check in the change into their system and have it application and business logic updated in production. Security in DevOps, it's not only about vulnerabilities of application code, but we also want all compliance applicable to data, schema, and database changes to be at place, including encryption, for example. And of course, audit and repeatability, what we talked about. We always wanted to understand what caused any issues in production system. Next slide. So let's look at this specific case we wanted to discuss. This is our CI/CD abstract example of the pipeline. And we can see this actually database is definitely part of this. So engineer would check in database change is all known as migration to Git repository. The recommended format typically XML because data agnostic. The change triggers DevOps pipeline that reads an XML, creates a change set, execute the change, and test the database change, which can include testing of data itself and data logic, like whatever, if you have like any stored procedures. But it also includes the latest application code compatibility with the database changes. If test passes, the change is promoted and the environment database upgraded. If it fails, the change should roll back and the engineering team should be notified. So there is no like significant difference between the application code and database code in like when we're talking about CI/CD. Liquibase maintains a history of changes and sequence of the changes. Besides CI/CD, Liquibase also can be good to stand up your sandbox or temporary environment from your previous backup, for example, and you can get all all artifacts that you need from the Git repository to replicate the version of application code and database code needed for the current experiment. Either you debug something or experiment with a customer experience. Next slide.
Wonderful. Thank you, Marina. Let's take a quick pause to do another live poll. So this poll, one moment, we're asking, what's your biggest hurdle to DevOps adoption? Is it budget, lack of prioritization, lack of ownership, lack of app dev support, lack of DBA support, or just a lack of clear first steps? I'll give everybody a moment to submit here. I'm excited to see. All right, about 5 more seconds. All right, let's see what we've got. Okay, we're pretty split. Interesting. About 20% of us lack of DBA support, another 20% lack of clear first steps, closely followed by budget. Then we've lack of prioritization, lack of app dev, and then in the last, lack of ownership. Interesting. Marina, Pete, what are your thoughts on that?
I think it's because we rarely talk about database DevOps and how actually DevOps evolve with like current the system design and the cloud. I think I even see the questions in our Q&A that's actually replicated is how to approach version control and continuous integration for database. So we will definitely try to cover, Pete. I think it's your demo and your detailed diagram of implementation example is going to be critical here. What do you think, Pete?
Yeah, I think it's going to be, the demo is going to sort of satisfy a lot of the questions that have been asked already. And I think that is reflected in the poll as well. A lot of people are really looking for, how do we take the practices and processes that we've implemented for application code over the last 25 years and, gain the same benefit from a similar process from the database. So I think the demo will definitely be interesting. Another one I want to talk about just briefly, the lack of DBA support. I think that kind of goes to Marina's points on culture, how important it is to make sure that you're aligned internally, that you're solving the social problems, which are the first problems of DevOps that need to be solved in order to make progress. And really just kind of all getting on the same page about what it actually means, how it's going to impact the job. And really what we've found over time is that once, you work with the DBAs, you talk to the DBAs, you understand what their issues and needs are from any sort of automated process, they are very quick to get on board, because with the acceleration in deployments and the, explosion in the types of databases, they really are being asked to do more than ever before. So it's interesting. I like how it's also kind of all evenly split as well.
And I think it's also come to the culture of where's the which one responsibility of the each person in the team, right? Because with the serverless database, a lot of heavy work of the DBAs has actually went away. So it's who's still responsible to roll database changes? Who's responsible to audit? Who's responsible to monitor, observe, and who's responsible to debug it, right? And we see totally different answer across different companies. I think it's first to agree inside of the organization and the team who is responsible for what, agree what the process look like, and then it comes to the tools, right?
Absolutely.
So, back to you, Tiffany. Go ahead.
Oh, sure. Yeah. I'm gonna talk a little bit about some of those issues and more in the next few slides before we get to the demo. But it really is about, the database is a different beast than application code or even configuration or infrastructure. It has some specific and unique requirements that need to be taken into consideration as you're thinking through CI/CD for the database and DevOps for the database and any sort of automation. So as you're starting on this journey to bring database fully into all of the advancements that have been made for the application code and other areas of the application stack, these are the things that I think are important to really kind of stop and consider. So the first piece is your process needs to be scalable. Really what we're dealing with there, we need a standardized, flexible process or collection of process templates that are ensuring consistency across all of your applications, all of your teams, all of your different databases, really across the organization. And that's really what's going to drive sort of an increase in consistency in process, but also continual improvement, continual evolution, and rapid rollout of the benefits of automation and CI/CD pipelines for your database. Managing, if every application you have has its own process defined by a different person, not only do you not know what's happening in all of those processes, but managing them at scale, especially when you're in a huge organization with maybe hundreds or thousands of applications or microservices that you're managing from day to day, managing those things at scale becomes really, really difficult. And getting insights into what's being done in those processes also really, really difficult. You multiply that across the different types of databases and the more frequent updates, and all of a sudden you really don't know what's going on without spending hours and hours just reviewing the results for each one of those. So kind of bringing those processes into consistency, no matter what your database is, no matter what your application stack is, and taking sort of a templatized view, sort of a config as code kind of approach to how you're managing that database build process really is critical. And when you do kind of drive it into those templates and you have a finite number of possibilities, it makes it a lot easier to evolve those things. You change that template in one place, that change is propagated throughout your organization for the people using that template. And there's not a lot of, going to each job to update everything, whether you're using it or not. So really just kind of getting this on the rails, reducing the cognitive load of starting a build process and managing a build process, and getting consistency across the organization really is critical to unlocking scalability, rolling out more quickly, updating more quickly, and having less friction in the process as your processes evolve. I'm going to go to the next slide. Next, this is one that, we've had a version of this slide for the 11 years since we started the company around Liquibase. And it really is sort of our founding concept is we've got all of these great practices and approaches and tools that have built up around the application stack. And really what we need to do is use that as a map, as a guide. How can we take the database with its unique requirements, with its stateful nature? How can we take the database and bring it into a similar process, bring it into lockstep with the process that we have for our application code? So this means things like versioning and source code control your database changes. It means bringing it into automated build and deployment. And then it means also bringing it into some of the advancements around quality and compliance and governance with code scanning and things like that. So how can we take the database, which could be the language could be SQL, it could be JavaScript, it could be CQL. There's many different ways that a database is interacted with. How do we bring those databases into a similar process and provide the same level of assurance and automation that we have provided for the application code? Because that's really when you're going to unlock a lot of operational and organizational excellence. When everything is moving together through a well understood, consistent process, you're really going to see a quick acceleration in change. You're going to see a reduction in errors, and everybody is just going to kind of have a sense of, these two things are the same thing, the application and the database. You can't really have much of a fun application without the database. So really, they need to be thought of as one and managed as one, moving through the pipeline like your application code does today. You want to go to the next slide? So testing and compliance, that needs to be part of your pipeline. Right now, we've talked several times about the manual process that we've historically used to manage databases in an organization. And that was really critical to have experts like our expert DBAs reviewing what was going into the database to make sure that everything was being protected. We needed to make database change safely and make sure that we weren't negatively impacting availability, security, performance, auditability, data integrity. There are just so many things that could go wrong with the database change. And because the database is stateful, particularly relational databases, once you've made that change, you can't just blow it away. You live with that change now. You either have to figure out how to roll forward if it's bad or roll back if it's bad, and make sure that whatever the remediation is propagated through all your pipelines. So really avoiding those bad changes is the best solution. An ounce of prevention is worth a pound of cure, and I really fully believe that. And this involves bringing things like code and database scanning into your automated processes. You can also use security vulnerability scanners, things like that. But it really is about making sure that we are paying very, very, even much closer attention to the database code that we're propagating through our pipelines than the application code, because those changes are so much more permanent and so much more difficult to unwind. Go to the next one. And then also, obviously, security. Some of this you can get through some of the implementation, or some of the things you implement from that previous step, looking at things like code scanners and things like that, but really also making sure that our DBAs, the automation we provide are helping our DBA scale, so they can really focus in and making sure that that aspect of configuration is taken care of as well, and that anything introduced to the database isn't going to cause a security vulnerability or something like that. So really just making sure that our processes are taking that database code and scanning it, and then in our infrastructure using roles and policies and IDP to kind of enforce who can do what within that infrastructure. And that's something that AWS, I think, has always done a really fantastic job for. You can get as granular as broad with your policy definition as you want. And that really is, that's really helped a lot of our customers dial in that separation of duties, make sure that people have read access to what they need to read, they have edit access to what they need to edit, and no access to things that they have no business dealing with at all. That's also a very important part of it. And then also considering where you run your updates. Really, you want to make sure that that pipe between where you're executing your database updates and your infrastructure is highly secure. A lot of people keep everything in the same network segment behind the same firewall, but with the advent of SaaS solutions, things of that nature, you really do need to make sure that the pipeline from that SaaS solution to your sensitive infrastructure is very well protected as well. And for our final consideration, the right level of visibility. So one of the things that you sacrifice when you automate a lot of things is just sort of the innate knowledge of what's going on in the organization. Because you're making changes so much more quickly, and because machines are making the changes instead of you, it would be and because change is accelerating, there are more changes, it would be very easy to lose sight of the forest for the trees, right? You could lose just sort of that innate sense of what's going on in your environments, and how well your teams are performing and what your processes are. So really making sure that out of that automation, we're extracting the right insights, the right observations, the right metrics is critical. You've got to be able to present that back to the team. If you're asking them to seed control via automation, that automation needs to prove to that person that it's doing a good job and it's doing the job it should. So elevating that visibility of what happens in automation to the appropriate stakeholders absolutely has to happen, especially when you're dealing with something like the database, which could hold very, very sensitive information. You don't want to breach. You don't want to lose data. You really want to make sure that your services and your experiences maintain a high level of quality. And in order to do that, the people who are behind the keys need to really understand what's going on in all of those environments. Next slide. So that's really what Liquibase was born to do. We started this company so that we could bring DevOps to the database, so we could increase the agility of databases, so that we could bring some of the tried and true practices around build automation and continuous integration and continuous delivery to the database. Because that really, if you're only solving one part of the problem, you're only solving the application code part of the problem, the database is going to become an anchor. It's going to become a drag on that process. And it's going to hamper the kind of advancements and the kind of improvements that you can make. So really, you've got to address both. You've got to bring them into a similar process, and they need to move together and provide the same information, kind of a cohesive experience around the updates of those applications and the updates of those databases as well. So in terms of Liquibase and AWS, Liquibase has always been a big fan, and we've always made sure that we've got the proper support for the purpose-built AWS data stores. And that's not just because we're rah-rah, we love AWS. It's because many of our customers are migrating to the cloud, or they're starting greenfield projects in the cloud, and they're using the purpose-built databases that AWS provides. So currently in the product, we've got full coverage for Amazon RDS, Amazon Aurora. We introduced Document DB support this year, and we have Amazon DynamoDB support coming in 2024. So it's, for a long time, it's been a great partnership. Our customers are using the databases that AWS builds, so we want to make sure that we support all of those databases as well. So we're now on to the live demo portion of our presentation today, and I'm pretty excited to show it to you. So what we're going to see is an application and a database moving through the same CI/CD pipeline, same time, with all of the same sort of bells and whistles that you would expect for application code. I'm going to take a quick sip of water here. But the process I'm going to show you today is going to start with our developers. They're going to be making code changes both to an application, a PHP application, and to the database, the MySQL database that supports it. And they're going to be putting those into AWS code commit, AWS's Git solution. That commit into code commit is going to trigger an AWS code pipeline. And that code pipeline is going to use code build and code deploy to update the Amazon RDS instances and the EC2 web servers respectively. As that process is going on, a few things will happen. A lot of the configuration that we use for code build will be centralized in an Amazon S3 bucket, and that's part of that security story. What you'll see is that we'll have sort of our build flow defined there, and we'll also have our code scanning, our quality checks configuration there as well. That makes it available to everybody who's part of that team, so developers can run it from their workstations, but it's also going to be run in our automated process. So you get that consistency of process, and you also enable some of these things to ship left. So a developer can do a lot of these things before even committing to make sure that the changes that they make are going to be acceptable and are going to flow through the system without issue. We're using Amazon S3 to kind of host that common configuration. As we go through the process of updating our environments, we'll be sending our logs to Amazon CloudWatch. CloudWatch is a great way to sort of centralize and share logs, but also gain insights operationally from what's going on. And using the Amazon Managed Grafana service with the CloudWatch logs, that's going to allow us to build dashboards and visualizations of that operational data that help us gain that understanding of what's going on in automation, and also to track our performance and our progress. But also, as we're going through this build process, the Amazon Simple Notification Service, as we get to, through each stage of the pipeline that you'll see, they'll be sending emails to the appropriate reviewers for whatever that stage of the pipeline is. So before moving on, we'll at least get some human eyeballs on the changes that have been made, make sure there aren't any major database issues, and then we can move on through that pipeline. And with that, I will share my screen. Okay, here we go. Okay, so what I have here is my simple PHP app. And this is actually from a tutorial on the AWS site. It's just a simple directory application that you can set up to get comfortable with connecting an EC2 web server to an RDS database. It's a simple directory. It's got a name and address. I put some data in here, but it's not the most attractive app. It's pretty unstyled, and really it's just name and address. It's not the 1800s, so it'd be great to have a phone number or something in there, and that's what we'll do. But I've got three environments. I've got this integration environment. That's my first stage. Got a staging environment where we would expand scope and let more people review changes before they make their eventual way to production. And then I've got my production environment as well. So 3 different environments, all as part of this pipeline, all with application code and database code to deploy. So next, I want to start with the developer experience here to show a bit about what it's like to work with Liquibase as part of your application development workflow. So this is my repo. This is what's getting pushed into code build or code commit to trigger the pipeline process. It's a very simple repo. This local directory is ignored. It's just where I put log files and things that I don't really want to commit, but I need to as part of my development review. Scripts are something that are used. I've just got one script, and really it's used in the deployment of my application code files, just to make sure that everything is updated nicely and everything behind it is cleaned up. So we don't need to worry too much about that. Then we get into source. So the first subdirectory in source is changelog. And this is where I define the database changes I need to make as a part of a given application update. So you see I have 4 files here. one YAML file, and 3 SQL files. So the way I've decided to structure my changelog is to have the YAML file kind of says, okay, these are the distinct changes that I need to make for these different versions. And it does that by including the files below it. So I've got all my database changes for V1 are here, all my changes for V2 are here, all my changes for V3 are here. I can label these so that if I want to deploy only one or only two, I can just kind of drill down into just that file to deploy that version of the application. But this overall main changelog, this root changelog, allows us to sequence how these things are deployed. So instead of relying on, sort of alphabetical files and scripting in order to deploy changes in order, you can be really prescriptive about how these things are deployed, in what order they're deployed. And you can also affect certain aspects of the runtime as they're deployed. But this is sort of the starting point. If we had a version 4, we would just add a different include with that version 4 file, and it would run after version 3. It's going to run top down in order, the changes, and it's going to run everything in that V1 SQL file, everything in that V2 SQL file, and then everything in that V3 SQL file. Let's take a closer look at what one of these files looks like. So here we have our formatted SQL changelog file, and you'll see there's 2 comments here at the top. The first comment alerts Liquibase that this is formatted for Liquibase to use. And what that means is Liquibase is going to look for instances of our next comment to delineate how changes are deployed. Each delineation is known as a change set. So a change set is, typically one change, sometimes a few changes, depends on the nature of the change, that accomplishes one task as part of your deployment. So here I have a change set where I create my employees table. This is the author, so I'm the author of it. This is the title of the change set, and then this is the change I need to make. So really, the way I've seen developers work with this is they'll either work directly in the database and generate a difference, a diff to come up with the SQL, and then they annotate it to break it into change sets and prepare it for Liquibase. Once a change set is executed successfully, it won't be executed on that database again when you run Liquibase update. That is part of the beauty of Liquibase, is once one of those units of change, once some of those change sets are executed, you don't need to make special considerations about your next update. The database keeps track of, oh, okay, this has been run. I don't need to run this again, but this is new. I'll run this. That's a very, very powerful piece and sort of a core piece of Liquibase. So we're able to break our changes into these atomic units. Once we deploy them, we don't need to specify in our next update that we don't need to deploy them. We just keep running the same command over and over as we iterate on the changes we make. So that is really a huge benefit and a huge time saver, a huge efficiency driver in the deployment process. And if we look across the different, for each one, I've got different sets of changes that need to be made. So in this one, we added a couple of tables. And then finally, in this one, we added even more tables. So that's really what we're looking at doing here, is providing that that versioned experience for the migrations that you need to execute in order to get your database in the appropriate shape to take a specific version of an application. So each one of these is tied to a different version of the application. You can also write change sets in a few sort of abstraction models. So you can use JSON, you can use YAML, you can use XML to create your change sets. And in those cases, it really is just what we'll do when Liquibase runs is we'll take that model and we'll generate the SQL you need for whatever database you're going to, and we'll apply those updates. So if you have a change log written in YAML and you're pushing it to a Postgres, we'll take that Postgres database, we'll take that YAML model, and we'll use that to sort of generate the SQL that needs to be executed for that database. A lot of people, by and large, most of our customers, comfortable with SQL. They use SQL, but they do have options. They can use more model-driven approaches as well. The next file I want to show you is the build spec. So this is what code build. A little more screen real estate here for this. This is what's going to tell code build what to do. It just kind of gives them the step-by-step instructions. And I want to show you this because it's pretty simple. We're using the standard Liquibase Docker container and then we're running a few commands. So in our install phase, we're making sure that we have our S3 extensions so we can read files from S3, and our MySQL driver so we can communicate with the MySQL database. And then we're really just running one command, Liquibase flow. And that Liquibase flow command, in this case, we're passing one of our parameters here because I wanted to demonstrate that you can really kind of put parameters in many different places in order to affect the execution. But it's a very simple command. And that flow is what's going to hold the definition of the build process for our database. The flow file that we're using is this. So this is a Liquibase flow file. This is a Liquibase convention, and it allows you to organize actions into stages and to have multiple actions. People can use Liquibase. You can, use shell commands to really put together as simple or as complex a workflow as you like. In this case, it's very, very simple. So we're going to first validate our changelog. This is one of our stages. We're going to run the Liquibase command checks run, which is one of our code scanning capability. And then we're going to validate the changelog to make sure that it's well formed, and we're not going to run into any sort of issues with Liquibase running with this changelog. Next, we are going to tag the database so we can get back to our starting point, and we're going to run status. So in our log, we'll have a record of what's been deployed and what hasn't been deployed, so that we can, if we are troubleshooting something, we can go in and get a real clear picture of the starting point of that database. Next, we get to our update. And then finally, we're going to run our checks again, but this time we're going to run them on the database instead of on the changelog. So at the beginning, we make sure that the changes we're about to deploy are acceptable, pass all of our criteria for an acceptable change. We're going to deploy those changes, and then we're going to look at the database to make sure that we're left in a state that is also acceptable to us. And I'll have a couple of simple examples of each type of check here in just a second. But that's our build file. And what you'll notice is there's no specific data about where my database is. There's no specific data about what changelog I'm using. There's no specific data about what my configuration for the quality checks is. All of that is abstracted away. And like I showed you in the build spec, you can provide it as command line parameters. What I like to do is provide as much of that as possible in environment variables and different scopes within my pipeline. I'll show you a little bit of that when we get over to AWS. And then these are my local properties. So this is how I'm going to these are the properties that I'm going to use when I am developing locally. So I've got the database connection information for my Docker MySQL database that I'm running here locally. I've got, for my build files, my check settings file is that S3 file, is in that S3 bucket I was talking about. So we've got those check settings in one spot that can be accessed by multiple people. So I'm going to be able to use the same file that's used to validate builds in our pipeline locally on my changes before I even commit them. So talk about shifting left. You now kind of have the power to make sure that you get that review in before you push it to the integration process. And it's the same review that's going to be run as part of that integration process. And then I'm also using the same flow file that I'll use in my build process as well. And that's the flow file that I just showed you. But I'll be using it here with my local database before I push those changes up to code commit. So to show you how that works, I've got some changes staged here, and I'm just going to run Liquibase flow. So Liquibase is firing up, and it's now running through those distinct steps that I showed you in that build flow file. So we'll just go through this real quickly so you can see those distinct steps. But what we're looking at here is first we're validating our changelog by running our checks. So as we ran our checks, we looked through those different changes. It doesn't look like there were any issues with my changelog. So that's great. If there had been issues, it would have given me a warning, and I could sort of compose whether that is a blocker or it's just informational, and get that immediate feedback about the changes I'm about to make that is going to prevent issues in the build system. Nobody wants to break the build. Nobody wants to stop the CI/CD pipeline. So get that stuff straightened out before you make that commit, before you push that branch. So then we went through our steps to tag the database so that we could get back to that point if we needed to. And then we ran status to see what would be deployed. Then we generated the SQL. So I could review this SQL to make sure that it matches my expectation of what would be run. It also gives me a real clear picture of what is going to happen as part of this update. We execute our updates, 9 of them. They all succeeded. And then finally, we did our Liquibase database checks. And my database check did turn something up, if you look right here. So I had a check that looks to see if all of my tables have an index. I enabled it, but I made it informational because maybe we need to deploy a table and then we'll figure out the indexing strategy in the future or in the next iteration of change on that table. So when you do run into these issues, they kind of gives you a description of what the issue was, what the change set was, or what the database object was, and gives you sort of the high level information about that. We also see here that these are the types of objects that we scanned. And we were, as we see, we've got 7 tables, 6 indexes. So that's where we ran into an issue with that table. But because it's just informational, I'm going to go ahead and push the changes and we'll deploy them broadly. So then just kind of looking at history, this also tells us all of the deployments that I've done in the past. So I had this deployment and then ran all of these deployments at about the same time. And now I am ready to commit. So we'll jump over to AWS and we will show the process there. I'm gonna minimize these for a second. So right now, let me just refresh to make sure that I'm still logged in. I figured that out. One moment. Code build. Oops, no, code commit. So this is our source code repository. And I'm going to go pull request. I have a pull request staged that is going to make some updates to the application that I showed you a second ago. We've redesigned that employee directory page. So we're going to rework the layout based on UX feedback. I added a database and form fields for employee phone numbers, and I applied our brand standard styles. We can look and see what our changes are. So first we'll see I made some changes to my change logs. So I'm including those next 2 files to get us to version 3. This is what's included in those files, so we can see what's net new and about to be deployed. And then I've got the updates to my application, and I've got the addition of a style sheet to make it look a little more attractive. So all looks great to me, mostly because I wrote it. You shouldn't review. This is not a best practice. Don't review your own pull request. But I'm going to go ahead and merge it because I have that power. So once I merge this pull request, we're going to come over to code pipeline and take a look at that. So this is my CI/CD pipeline, and it's going to update my database and my application at the same time in through 3 different stages. The first step, which should be kicking off automatically here after that merge in just a moment, is to build an artifact out of my source code. The files that make up my application, the files that help me update my database are all going to be built into an artifact that's used to update each one of these environments. And as we can see, my automated process is just kicked off. In each stage for the integration environment, the stage environment, and the production environment, there are 3 steps. So the first thing I'm going to do is update my database, and that's what's in progress right now. Next, I'll update my application files, and then finally, I'll pause for a manual review. And then that's repeated for my stage and my production environments. But to dig into this one a little more specifically, I want to show that what these look like. So before, when I was talking about having the extracted templates and then providing the runtime information in a variety of ways so that you can scope it appropriately, that's what's reflected in this build job. So I'm using a build job and code build that I set up. I'm using the source artifact. So that's the artifact we made in the previous stage that I referenced a second ago. And I'm using this build project, and we'll go take a closer look at this build project in a second. But as I update my integration environment, I've got a certain set of environment variables that I'm setting. So up top, we'll see this is the database connection information that I need to update the database for this environment. And I'm storing all of that in Secrets Manager. That's a security consideration. Not only does it keep the actual URLs and the credentials from everybody, giving access to everybody, it's also going to take those values and scrub them from my log files. So it'll make sure I have a nice safe log file. It'll make sure only the people that have access to those secrets can use these things, and it can build out that process. The next several, I've used the pipeline variables that I'll show you in a second to specify, what needs to be used in that runtime in order to accomplish the job of building out that database. So that's for my changelog file. Where's my changelog? where are my check settings? Where's that flow file? What do I want the logging to look like? And then finally, I'm setting an environment variable to indicate I'm in the integration environment. And this, I'm doing this so that I can, when I look at a log, I can understand what environment I'm working in without needing to rely on that JDBC URL that's now being scrubbed, from all of my logs. So this is everything that I kind of need to set up in order to run that database build job. And it's the same across all of the various steps. So these are the pipeline level variables. These are the AWS pipeline variables that I'm using to populate some of those other environment variables in my build job. So if I change what check settings file I need to use, I just need to change it in this one place. If we change what flow file we're using, we just need to change it in one place. If we're making changes to logging, we just need to change it in one place. And then it's going to propagate to each one of those steps, the build job in each one of those steps. So I'm updating one field. I'm affecting broad change throughout my pipeline. I've done so very safely and consistently. So that's kind of a look at the pipeline at a glance. Let's my changes. Excellent. So it looks like my integration environment deploy succeeded. I could click in and view the logs of that. The application update succeeded. And then we're waiting for a manual approval. In this manual approval, in each stage, there's a different SNS topic that's used to notify the people who would need to validate that environment. So in integration, it's most likely DBAs and developers. In stage, it might be the business owners or other people that are, waiting on features or new capabilities to share with customers and make sure that they work as expected, kind of your user acceptance testers. And then finally, production, would use another SNS topic to send emails to a different group of folks that are required to review production updates to make sure that there's nothing glaringly bad. So now, instead of using that link, I want to look at the integration phase my app, refresh it. Hey, look. So we've got a much more attractive site. We've got some navigation added to it. We've got our styles to it. We see that we had this data before and we had a default phone number that we entered for old entries, and that's been applied. So this update has gone successfully. I think we are in good shape to promote that through the rest of the pipeline. So I will review and I will approve that. So while we're running through our next stage, I want to take you into the build project just to show you what happens there. So this is the same build project is used for every step in that update. And because if you remember, the thing that controls our build project is this build spec file. It's a very, very simple approach that we're taking. All our build does is run a Liquibase flow, and that's our Liquibase flow. And then tying it all together, when we were looking at our pipeline, as I drilled into that build project, you saw all of those environment variables. That's what gives the Liquibase and the flow file the context it needs to complete its job. So we've got a very simple templated build spec. We've got a very simple templated build flow that Liquibase uses. And then it's all about the environment variables and the parameters and how those things are managed. So looking at our build file and its configuration, we see, the source code repo that we're tied to. We see the environment that we're running in. So this is where we're running our Liquibase Docker container and configuring that. And here we've only got one environment variable in the build job by default. And that's because we don't want to manage it in each one of those individual instances of the build job. We just want to manage it in one place. And that's our Liquibase Pro license key. Liquibase Pro has additional features on top of Liquibase, and I'm using some of those today in this demo. But by providing that license key here, you really only need to have it in one spot. And if you get a new license key or it updates, you just go in, update it in one spot, and it's going to apply to all the builds that use this build job. So very simple way to kind of show, by scoping our environment variables, we're updating things in one place instead of several places. And we're really gaining the full benefit of those templatized workflows in doing so. So it's really it's a very simple build job. It runs the command Liquibase flow after setting up that Docker environment. And that's it. It runs that. And that's what kind of comes out of our build process. To show you what that build log looks like, This is an example of a failed job that I did earlier. But what you can see is much like the console output when I was working in my development environment, you see us going through all the different stages of our flow. And when we hit an issue, it becomes very apparent because we get these stack traces. And we can see that we had migration fail for one of the change sets in this build. And as digging further, we'll see that the table already exists. So, oh, okay. I mean, I tried to make a duplicate table. That's why my deploy failed. But this is the kind of log file that can be automatically sent out to someone to review manually, but it's also the log information that we're going to use to build our Grafana dashboard, which I'll show you in just a moment. Actually, we'll jump over to that Grafana dashboard now as our environment continue to update. Oh, we can now review our stage environment. Let's go ahead and go to that. Refresh. Yep, we have the same thing. So this looks good as well. We've got all of the updates made. Our data was preserved. We added defaults for the new fields. So this is good to go. We're going to go ahead and update for production, or approve that for production, and that'll move on. So you've got this automated process. You've got detailed logging that's coming out of it. How do you keep people informed at a higher level? Not everybody loves to read log files. I kind of do. I've spent so much time kind of staring at them that I can cross my eyes just right and pick out what I need from them. But that's not an experience that everyone enjoys, especially somebody who isn't deeply technical or knows what's going on. So you can take those structured log files and you can do things like this. You can start building dashboards. This is the Grafana managed service for AWS, and it's looking into CloudWatch where my log files are stored. It's running queries and it's creating these metrics and these views into my data. So very quickly, I can start at a high level. I can see that I'm deploying to prod 4 times a day. That's great. If you're making little changes that are going through quickly, you know you're doing the right things. You know you're making progress. So I'm deploying to production 4 times a day. Smaller deployments, but they're going through. And this really only counts successful deployments. Next, we have our pipeline-wide expression of our failure rate. So why don't we just focus on production here? Because in order to understand your process and how well you're doing, you need to understand at each stage where you're failing and how often you're failing to get just a general sense of that information. And then we can also calculate our lead time. So really all this does is say, okay, this change set was deployed in integration on this date. It hit production on this date. I'm going to, subtract the production date or subtract the integration date from the production date. That's how long it took my change to get there. And then I'm going to average that across all of my change sets. So this really just kind of tells you how long it takes for a change to go from inception, an initial commit, into production. With a lead time of less than 2 days, fantastic. And I'm kind of bragging on myself because this is the demo environment that only I've worked in, so I can say whatever I want. But these are the kind of insights you can have. It's no longer like, oh, I feel like we're slow, or oh, I feel like we fail all the time. You've got concrete examples that are really, really easy to understand quickly. And you can also break that out into each one of the environments as well. So here I'm tracking what our failure rate is in each one of the environments. And this is great. Most of our failures are happening in integration where they should. The whole concept of shifting left and finding things early, that's where you want to find things. One thing has slipped through to staging and I've been perfect in production. Perfect. And then you can even get more granular. So you can keep running lists of what our quality check violations are and how often they're being run into. So we can see here, we've got issues with column naming, with people trying to drop tables, people not including indexes, people granting things they shouldn't, and also people not following our naming conventions. So you've got insight into that. You can see the outcomes of your builds and just sort of focus in on what you want to know. So if you want to focus in on the failures, there you go. You can see what stage it failed in, and then you can even get a real clear view into what that failure was, just all directly from this dashboard. And then finally, with the change set execution history, this tells you when a change set was deployed to an environment. You can see the exact SQL that was run as part of that deployment, and what the outcome was. Again, we can focus on where we've done well, we can focus on where we failed and what's caused those failures. But just kind of taking all of that structured information, bubbling it up like this, is a really powerful tool, not only to gain operational efficiency, but also to get that alignment, to show people this is sort of the level of visibility that you're going to have at your fingertips if we adopt these tools and these processes. And that is about it for the demo. Let's see.
Yeah, Pete. We are at the top of the hour, but we have so many questions, and even I'm trying to answer some of them offline. I think I want to still to talk about a few, which are mainly about best practices and concept of Liquibase. So I think I first, like I wanted to address is rollback mechanisms and Liquibase, because I see like a couple of questions on this topic.
Sure.
So go ahead.
So really, our best practice, what we recommend to people in a perfect world, is that you roll forward, because undoing a change could have unexpected negative impacts on data. And then you have two problems. Your roll forward didn't work, and then your roll back didn't work. And now you don't know where you are. You're in this new kind of no man's land third state. That's not realistic for everybody. A lot of people need to work rollbacks into their process. So Liquibase lets you define for each one of the change sets that were part of that change log. You can define the specific rollback instructions to take, and then you can execute a Liquibase rollback command. And it will, depending on the parameters, it will look for the changes that you want to roll back, execute those steps, and hopefully complete successfully. But yeah, really, while we do have that built into the framework, it really is better to think about, okay, well, how can we roll forward? What kind of change can we introduce to get to the state we needed to, so we can unblock this deployment?
Okay. How does Liquibase maintain and track the history of the database changes to know which changes it has applied and which changes it hasn't? Does Liquibase actually store a state somewhere, or does it infer at runtime whether or not changes have been made based on the current state of database and expect a result of the given change? Because the example is basically one person made update manually to database, second person tried to update the same, like using the scripts.
Right. So first of all, we want to avoid making both manual and automated changes to a database. You're going to have the best outcomes when everything goes through automation. That's where you're going to get the consistency, 100%. The governance, all of the benefits of what you've built. In terms of keeping track of the deployment state of the database, we do create two database tables. It doesn't have to be in the same schema that your database objects for your application are, but we use those tracking tables to keep track of what was run and when it was run. And then the second table is just to make sure that two concurrent Liquibase processes aren't trying to update the database at the same time, because if those collide, it can lead to issues. But really, there is that database change log table that tells you what was run, what change sets have been run on that database and when. And that's what Liquibase uses to determine, okay, well, these haven't been run and I need to.
Yeah, and I think it addressed Adrian's question, how Liquibase handles change set for different database version upgrades, and how Liquibase change set logs peg it to specific DB version. I'm pretty sure it does. So next one is, do you need a separate repo for each database, considering there is a configuration log file associated with database?
It really depends on how your team works best. I mean, ideally, if you're working in a microservices environment, you've got a repo for each service, and it can have the application code and the database code, and then it just uses that database code on each one of the databases. But we have seen cases where customers are sharing databases where they will have different repos depending on what their function is or what they manage and update in that database. So it is, it really is up to the user. I think it's great to have your change logs in the repo with your application code and just use that one repo to update your service in your database or your application in your database at the same time.
Great. Let me see. It's like there's so many still. And guys, if we don't answer anything, we will try to answer offline of whatever, because like we'll just follow up. So I'll do just one more. Oh, it's hard to pick. So I'll just read the one I have in my screen. How would you plan CI/CD when your team has a shared database among several applications? Note the database and application are on its own Git repository, so it's needed to use Git submodels to add the database in each application.
Okay, so there's a shared application, a shared database,
multiple teams, shared database. Everyone says on Git repository. So the question, so it is needed to use Git submodels to add the database in each application. And I think how you would plan CI/CD for that.
Right. So, I mean, because the change logs are so composable, I mean, you could, it's really best to keep your change logs altogether. So you have the full story of what that database is. But what I've seen people do is like that sort of root changelog model that I showed, where it's actually pulling in several files. You can have a directory for each application or team within that Git directory tree where their changes are managed. And then you have that root file that kind of pulls in changes that have been made to each one of those in whatever order you deem. But because everybody's playing in the same pool, everybody's using the same database, they really need to have a comprehensive view of what happens in that database. And they need to have an understanding of how the changes they make affect people across the way. So by having that change log in one Git repository and then requiring a pull request reviewer from each one of those teams for every change that comes through, really that's been a really successful approach that I've seen people take in managing that situation, because we do run into that a lot, whether it's legacy applications or huge data warehouse databases that several people are using. Having that description of the changes that need to be made in one place is fantastic. But then making sure that you get eyes on every change from from a representative from every team has been a great way to sort of manage those changes and making sure that we aren't colliding with each other as we're promoting change. And then Liquibase does have.
Yeah, go ahead. No, go ahead.
I was going to say Liquibase does have a capability, so you can just drill in and release the changes from one change log or one folder. So you don't have to release the whole thing all the time. It's just, each application still has autonomy of when they update their pieces of it.
We still have a lot of questions, but unfortunately we're running out of the time, Tim. And Suhan Kumar is like, your questions are amazing. I think I will spend half of the day answering it. But what we'll do, we'll just take them offline and type the answers and use our contact information if you have additional questions. It's really great to see so much interest, and you definitely understand how important it is. And hopefully we did a great job to explain why it's important and at least how to start and achieve it a little bit closer to the production ready.
Yes, thank you, Marina. Thank you, Pete. Thank you so much for your presentation today. And yes, if you did not get your question asked here live, we will follow up with you offline. Next steps, if you want to learn more, sign up for a custom demo. We can do a custom demo based on your specific tech stack. We've got documentation, and we've also got a 30-day free trial of Liquibase Pros where you can get in yourself and see what it's all about. So thank you all for joining, and have a wonderful rest of your day.
Thanks, everybody. Thanks, Marina.
Bye-bye.
Thanks, everyone.